Okay, MAP4C, welcome to day 64, first lesson in chapter 7 on annuities. Whatever an annuity is, that's what this chapter is called. Today, the 3-minute review, the goal is to review some stuff about simple interest and compound interest that you learned in grade 11 and in previous grades. So basically the 3-minute review was just some terminology that we dealt with. And I've got it all here rather than you watch me write it all out. The simple interest formula, I equals PRT. I is the interest, P is the principal. Principal is the amount that is invested or borrowed or whatever. R is the rate. It's usually given as a percent, written as a decimal, so it's a decimal number. And the time is in years. So we'll see that if it's not given in years, we kind of have to make an adjustment there. And that's the simple interest formula. And the contrast to the simple interest is compound interest, as we know. And the idea of compound interest is interest on interest. And you worked a lot with that in grade 11, and we're going to build on those topics this chapter. So different formula. It's got an exponent n there. In fact, this is a special case of the exponential functions we covered the last couple of chapters. So what do these things mean? A is the amount at the end. So after it's earned its interest, how much is left at the end. P is the principal, the amount that you invested or borrowed at the start. I is the interest rate per period, and N is the number of interest periods. So this interest rate per period ends up being a little bit of a pain in our butt because, if it's 6%, but it's compounded monthly or something like that, it's not like you get the 6% every month, right? That would be a lot more than 6% interest if you got that every month. The interest rate per period would be the 6%, and then we divide by 12 because per month means 12 times a year. We'd get not the whole thing every month. And the last part of the 3-minute review talks about those words. Often in these compound interest questions, there's a word like the interest is compounded annually or semi-annually or quarterly or monthly or weekly, and here's how often interest is calculated and added to the account. Annually is once, twice, 4 times, 12 times, and 52 times, and hopefully you remembered those. Okay, on to the lesson. This the 7.0 sort of indicates that it's a activate prior knowledge lesson, and that's what we're doing. We're talking about reviewing grade 11 stuff, solving problems involving simple and compound interest. So example 1 is Ferd's got is late with his cable bill. There's a 4% penalty and his bill is for that much. What's the late fee? Well, these sorts of things are almost always simple interest. So I'm going to write down the simple interest formula. And here's a formula. We've done some work with formulas, so this is just no different, right? What was the late fee? Well, that's the interest that he's going to be charged. The principal is the amount that he didn't borrow it, but he was late with his fee. The rate was 4%, but we write it as a decimal, so that's 0.04, written as a decimal. And the time is 14 days. Now notice if I put 14 in there, remember the interest formula is in years, so this would be like 14 years. So how do I make this 14 days in years? Well, I put it as a fraction, right? 14 out of 365 is the fraction of a year. So now interest is what I'm calculating, and I'm going to substitute into this thing and figure out how much interest Ferd owes. Straightforward calculator work. I just can multiply and then divide by, that's 14, not 19 there, folks. Multiply that times that times that, divide by 365, all in one line, and I ended up with 43.043. So what does that mean? Ferd's late fee was, 43 cents, right? Good. Next question, I believe, is a compound interest question. And There's the hint for you. That big word compounded usually means we're going to use the compound interest formula. And I'm going to write down the formula, and we're going to figure out what's what and what we're solving for. Ferd invests $400 for 4 years in an account that earns 4.5% a year compounded semi-annually. Well, there's that word. There's the word semi-annually. Means twice a year, 2 times per year. That's what that means. And where does all this stuff fit in? Well, $400 is how much he invested. So that's not the amount at the end. That's the amount that he invested. That's the 400. The I is, I can see that's 4.5%, 4.5%, but written as a decimal, 0.045. But I got to be careful though, because it's compounded semi-annually. So he gets 4.5 in the whole year. I divide by 2 to figure out how much he gets every half year, and that's the idea of the semi-annually. That's where that word comes into play. Okay. The number of interest periods, well, it was 4 years, but there's 2 interest periods a year, right? So again, that's where the semi-annually comes into play here. That's 0.0225. This is 8 interest periods, and then I can figure out how much Durf's going to have at the end of his investment. 1 plus 0.0225 to the exponent 8. And notice that right there, normally we wouldn't even write this step in. We'd write it as this. And again, we've got practice putting this into our calculator, but 400 times, we don't even need the brackets here. 400 times 1.0225, and then you look for your exponent button, right? Or on the graphing calculator, that's the exponent button. 8, and then press equals, and then you should get how much he had at the end was 477.93. That's how much was in the account at the end. Notice we weren't asked that, actually. We were asked how much interest does he earn. Well, this is how much was in the account. How much interest did he earn? Well, if we take off the original $400 that he invested, how much interest did he earn? $77.93, right? And I know your textbook probably has something silly like interest equals A minus P, but this formula here just kind of makes sense, I think. Good. Let's keep going. I think we just got one more example. Ferd wants to have $6,700 to buy a decent used car in 6 years. If he can earn blah, 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 blah. This is another compound interest question, right? There is a little twist here, though, isn't there? It's monthly, so I know the number that I'm going to have to deal with in there is 12, but this $6,700, notice if I think of right now, this is now, and this is at the end, right? This $6,700, is it now or is that at the end? Wants to have $6,700 to buy a decent car in 6 years. So this is 6 years gone by. He wants the $6,700 at the end. So what does that mean? That is the amount at the end, right? Here, the amount right now, how much does he have to invest is the principal, right? And so, in fact, this is a little bit backwards from what we were used to. Notice the 6%, 0.06, divided by 12, because of monthly, 0.005. N is 6 years, but 12 times a year, 72 interest periods. And now I want to solve for P. Now notice that this is kind of like those formulas we were working with last chapter. Do I rearrange first, or do I substitute then rearrange? And it doesn't matter. I'm going to actually rearrange first, because if I want to solve for P, I can get P alone just by dividing by that thing right there, and that's what I'm going to do. I'm going to divide by 1 plus I to the exponent n on both sides. And then I get this new formula, and it's not really new, right? And in fact, Some people will recognize this, and I wouldn't necessarily write this special, but this is from last year. This is the present value formula. Present value. And now if I wanted to substitute into it, I can. One, and notice the I is 0.005 to the exponent 72, and then I should be able to put that into a calculator. 6,700 divided by, if you want to put brackets in there, you can, 4678.63. And you should always think about these money questions. Does this make sense? So this number is smaller than the amount he's going to have to buy a decent used car. Does that make sense? Yeah, he's going to put $4,600 in change away. It's going to earn interest over the 6 years, and in 6 years he's going to have $6,700. So Ferd should invest that much money today. I think that's it for this for the first lesson here. Some homework is practicing both your simple interest and compound interest. All right, stay tuned.